So we have here the first example of our topic, solving a linear first order differential equation. So example number 1, solve the given differential equation, derivative of y with respect to x plus 2 over x times y equal to x minus 1. Okay, so following the steps, the first step is to put the equation or the given equation into its standard form of a linear differential equation, which the standard form is something like this. Dy over dx, then function of x multiplied by y equal to function of x. So let's check, let's compare. Is this given looks like this standard form, or is it already in a standard form of a linear differential equation? If your answer is yes, which is actually yes, so we just write down what are the items that we will use in the solution. Like for example, we need to know the integrating factor, right? Which is that is in terms of p of x. So first we need to find out what is function of x, p of x. So from the given, so this is the p of x, this one. So p of x equal to 2 over x. And what is our f of x? So this is our f of x. Okay, so our f of x is equal to x minus 1. Okay, after that, the next step is to find the integrating factor. So what is the integrating factor? The integrating factor, which is mu of x, or we have this one, mu of x is equal to e to the power integral of p of x dx. Alright, so we just substitute. So this is equal to e to the integral of p of x equal to 2 over x, right? Then multiplied by dx. So this is constant. You can put the constant outside the integral sign. So e to the power 2 times the integral of dx over x, right? Which is, in our integral calculus, this is equal to e to the power 2 times derivative or the integral of dx over x, that is ln x. Now, using the properties of logarithm, so we can rewrite this as e to the power ln x, and then this 2 here goes here. That's algebra. And we can rewrite this as, so we can bring this down, x squared, then ln e, where ln e is equal to 1. Okay, ln e is equal to 1. Therefore, our mu of x equal to x squared. Alright, so we have solved already the integrating factor, which is equal to x squared. So what's the next step? The next step is to multiply both sides of the dE. So this is our dE, differential equation, by the integrating factor. Okay, so writing down again the given differential equation, dy over dx, then we have plus 2 over x times y equal to x minus 1. So the third step is to multiply each term of the given differential equation by its integrating factor, which is in this case the integrating factor that we have calculated is x squared. So it means that you have to multiply this by x squared, multiply this by x squared, then there's this one also multiplied by x squared. Okay? Then after that, you just simplify. Now we can combine terms. So we have x squared times dy over dx, then plus, so we have x squared here, we have x, so but combining, we have 2 because x here cancels with this x, so there's still x remain above, so multiplied by 2 multiplied by y, so we have 2xy, then equal to, you can distribute and multiply, so we have x cubed minus x squared. Okay, now if according to the step number 4, the left side is the derivative of product of the integrating factor and y. So let's check if that's true. Okay, let's check this part here if it's really the product of the integrating factor and y. So what does it mean? So it means that it should be the left side. This left side must be the derivative of the product. The product of what? The product of mu and y, which is equal to, this is also mu of x times f of x. So let's check if that's really true. So if you look at this, derivative of, okay, I will substitute first the calculated mu of x, or mu of x is equal to x squared, right? This is x squared, this is our mu of x, then times y, all right, equal to, so this is x squared, then times function of x, where our function of x is this one. We have already multiplied this, so this is our result, no? This one, this is x cubed minus x squared. Okay, so we have already done the substitution here. This is our mu of x, then this is our f of x, so we have already substituted here. We're just writing it, and if you check, we have to make use of the product formula. So what is the product formula? We have derivative of u times v with respect to x is equal to u times derivative of v with respect to x, and plus v times derivative of u with respect to x. Okay, so let's check if this is our u. Okay, so if this is our u and if this is our v, so let's check if the left side here really the derivative of this. Okay, so u, sorry, this is u, this one, this is u, this is v. So u, the formula here says that our first term, this is our first term, this is our second term. Our first term is composed of u, derivative of v with respect to x. So our u is x squared, so x squared, our v is y, so derivative of y with respect to x, so correct, no? We have this for the first term is correct. Then next, the second term, plus we have v, our v is y. Okay, v is y, so we have y. Then derivative of u with respect to x. What is the derivative of x squared? Derivative of x squared with respect to x is 2x. So exactly 2xy. So therefore, the left side is the derivative of the product of the integrating factor and the y. Okay, so I will rewrite this. Derivative of x squared times y with respect to x equal to x cubed minus x squared. So the next thing that we need to do is to integrate both sides with respect to x. Okay, so when you integrate, so integrating this, so we have, okay, of course we have dx there. So what will happen, so we have dx. So this is just the reverse process. This is the we are this is the derivative of this. So derivative of this expression, the product, you integrate it, so it's just like you're doing nothing, or you just cancels out what you're doing initially, which is you're taking the differentiation and integration, meaning you have this, you differentiate this, okay, with respect to x, and then you integrate it with respect to x, then this just cancels out. So it means that the process is just reversed. So the left side just becomes x squared y, which is equal to, you can integrate this individually, so integral of this using the power formula. So, or you can do this, do it like this, x cubed dx, then minus integral of x squared dx. Alright, so equal to, this is power formula, x to the power 4 divided by 4, then minus x cubed divided by 3, then plus the constant of integration. Actually, we can have here, okay, just one constant. So x squared times y equal to this. So to solve for y, because our goal here is to express y in terms of x, or it can be our answer, but we can still simplify this or express this in another way. So if we solve for y in terms of x, we can divide both sides by x squared. So x squared y divided by x squared y equal to, so what we did in the left side, we have to do the same on the right side. So we have x to the 4th over 4 minus x cubed divided by 3 plus c, then divide this also by x squared. Okay, so on the left side, we have x squared divided by x squared, cancels out, so we have only y on the left side. On the right side, we have division of fractions. Okay, so it's the same as this one here. We have the numerator, denominator. So the numerator is fraction, composed of fraction, denominator is a whole thing, so this is understood to be over 1. Then by algebra, applying division of fractions, so we can write this as, okay, I'll move it here, y equal to, I don't have space here, so we have, then you flip this one, so the expression becomes x to the power 4 over 4 minus x cubed over 3 plus c. Then we have, you flip this, you invert it, so this becomes 1 over x squared. Then you can distribute this, or you can put the 1 over x squared here, then you distribute it and multiply. So we have y equal to, so this becomes x to the 4th over 4, this one, 4x squared, then minus x cubed over 3x squared, then plus c over x squared. So we can cancel the x squared here in the first term. So y is equal to, this is 1/4 x squared minus 1/3 x, because we have x squared here, we have x cubed, so there's x left, then plus c over x squared. So this is the solution to the given differential equation. This is the general solution. Okay, so that's it. That's how easy, to solve this problem, solving this differential equation using the steps given in the first video that I've uploaded a while ago. Okay, so if you have any questions, you may leave your questions or your message in the comment section below. Thank you.